Hello. Next question. First I will read the question. Okay. A thin strip 10 centimeter long is on a U-shaped wire of negligible resistance and is connected to a spring of spring constant 0.5 Newton per meter. Figure is given. The assembly is kept in a uniform magnetic field of 0.1 Tesla. If the strip is pulled from its equilibrium position and released, the number of oscillations it performs before its amplitude decreases by a factor of E is N. Before its amplitude becomes E times less. Okay. Its amplitude decreases by a factor of E is N. If the mass of the strip is 50 grams, its resistance 10 ohm and air drag negligible, N will be close to. You are given 4 options. Option A 1000, B 50,000, C 5,000, D 10,000. Okay. See, this is a very nice problem wherefrom you can understand the concept of damped oscillations. Right? People generally do not study much about the damped oscillations, or they do not pay much attention to damped oscillation in their class 11. Generally I am saying, okay, I am not saying everyone is like that. Generally they don't pay so much attention to this damped oscillation, but now there is a sum wherein we may have to use the idea of damped oscillation to solve this problem. This problem came in JEE Mains 2019 in one of the papers. 2019 Main in one of the papers. See, how will we do this problem? We have to see. There is a magnetic, see, this is a U-shaped wire, metallic strip, spring, magnetic field. You pulled it one side and released, it will oscillate. Initially, let us say that there is no magnetic field. Just to understand this. Only spring and the mass. So we know, we might have studied this. It is oscillation, undamped simple harmonic oscillation. Its time period t equal to 2 pi into root m by k. All these things we will know. So in that case, if there is no magnetic field, straight away we will write F as minus kx. So usual equation which you are all very much familiar with. But here, in addition to this, there is a magnetic field applied. So what will happen as the metallic strip moves, there is induced current. The nature of the induced current is to oppose the motion of the metallic strip by Lenz's law. So there will be an additional force always trying to stop the motion of the metallic strip. So let's say that is minus BV. We are going to find out why should we write it as minus BV. B is a constant. Why should we write V? That's we will be seeing presently. So here this B is known as damping coefficient or damping constant. This is the equation which involves damped oscillation. So F is mass into acceleration, d squared x by dt squared. Bring these two things to the left side. Minus BV will become plus BV, B into dx by dt. Minus kx will become plus kx. This is the differential equation, second order. So if you solve this differential equation and assume that B is very much less, let's say we assume, we are going to verify everything. If B is very much less, we say that the oscillatory motion is underdamped. Depending on the B value, you can say that it is underdamped, critically damped, overdamped, etc. We need not worry about all such things for this problem. B is very much less for this problem, which we will verify very soon. Therefore, here the solution for the differential equation for small value of B, B is damping constant, small letter b, will be given as, that is, solution will give you x value. From that you can extract the expression for amplitude. A is equal to A naught e power minus b by 2m into t. This gives you the amplitude. See, amplitude keeps decreasing exponentially. Assuming damping coefficient is very less and it is underdamped oscillation, we will verify whether it is true or not. So if you know, you are supposed to find the t, and it is given in the question A by A naught is 1 by E. So A by A naught 1 by E is 1 by E power B by 2m into t. 2m E power. Now left side E power 1, right side E power these things. So 1 is equal to B by 2m into t. Therefore, how much time it takes for the metallic strip to have its amplitude decreased by a factor of E? So T is equal to 2m by B. T is equal to 2m by E. Okay, I write here T, the required time is 2m by B. That is, it takes a time small t. How many oscillations it performs within this t, we are going to consider. That is in fact the question. So T is equal to 2m by B, small letter b. Small letter b is damping constant. So here we simply said small b, small b, small b. What is the small b? Nowhere it is mentioned in the question. But I said here this is damping force. So we will see what is the damping force due to and what is its expression. Damping force is due to induced current. Therefore, force due to induced current. Okay, so I just remove this. And we wrote T is equal to 2m by B. So I just remove this also. So damping force is BIL, F subscript D. B you write here, I induced current, so small letter E by R, again L. So B into small letter E, BLV, emotional EMF, we all know it. So BLV by R into L again. So B squared L squared by R into V. You see that? B into V, already I just wrote V, linear damping, it's called linear damping. B into V. So compare this with this. So what is our B value? B value is B square L squared by R. So small letter b, I just write here somewhere, small letter b, okay, is B square L squared by R. You substitute the values and see whether really B is less. Substitute the values. What is B? Capital B, 0.1, 10 power minus 1. What is L squared? 10 power minus 2. Because L is 10 centimeter, which is 0.1 meter, which is 10 power minus 1. Square 10 power minus 2. Divide by R. What is R? 10 ohms, so there is 110 here. Again B square, 10 power minus 1 square. So here also 10 power minus 2. So overall 10 power minus 5. It is pretty small, 10 to the power of minus 5. So damping is very, very small. So it is a case of under damping. Right? Right. Okay. So B value 10 to the power of minus 5. So I just list here. B value 10 to the power of minus 5. So you can find out how much time it takes for the amplitude to decrease to 1 by E times maximum amplitude. So here it is T equal to 2m, 2 into what is m? Mass 50 gram, so 0.05 kilogram by B. B how much? 10 to the power of minus 5. This is 10 to the power of minus 1 by 10 to the power of minus 5, right? Which would be equal to 10 to the power of 4 seconds. Therefore, within a time of 10 to the power of minus 4 seconds, sorry, 10 to the power of 4 seconds, the amplitude will become 1 by E times maximum amplitude. Now that is not the question. Question says how many times it will complete its oscillation. So if it completes one oscillation, the time will be one time period. So it's better to it is necessary to find out what is the time period of oscillation. Okay, so we will find out the time period of oscillation. This we already calculated. So time period of oscillation, capital T, 2 pi root m by k. So naturally there arises a question, even though you don't ask, naturally there arises a question. This is the time period of undamped simple harmonic motion, but what we are discussing is damped oscillation, damped case. If you want to really verify whether it is under damped, I said one method, just to find out B, small b, B very much less, okay, you can take it as under damped case. For that you can apply T equal to 2 pi into root m by k. If you want to be more precise, there is a condition for which you can even take this. Actually there will not be much difference between the time period of oscillation of undamped case and damped case when some condition is satisfied. What is that condition? The condition is, say B should be very much less than root 4 mk. All these things can be proved but not necessary here. So B should be very much less than root 4 mk means the time period of damped and undamped cases will not be much different. In fact, you can neglect. So T equal to 2 pi into root m by k expression for the time period of damped oscillation is justified. For that, this condition should be satisfied. So how do you verify this? We already found the value of B, 10 to the power of minus 5 already. Okay, now find out root 4 mk. 4, what is m? 0.05. What is k? 0.5. Okay, so this formula for the time period of damped oscillation is justified because the condition is satisfied. Equal to 2 pi m 0.05 k, how much? 0.5. 2 pi root 5 by 50, 2 pi root 1 by 10. Okay, even remove this. Two pi into root 1 by 10. So T equal to 2 pi This pi you take inside, that becomes pi squared. Usually we do an approximation. Pi square can be taken to be 10. 3.14 something. No, pi square will be 10. So cancel out this. You get 2 seconds. Approximate. So time period of oscillation, damped oscillation, is 2 seconds. But it takes a time of 10 power 4 seconds for its amplitude to decrease by a factor E. So how many times it will oscillate? So the number of oscillation, n is equal to, okay, it takes a time of 10 to the power of 4. 10 to the power of 4 means 10,000. 4 zeros are there, no? 10 to the power of 4. Divide by t, which is 2 seconds. This will be number of oscillations. So you will get this as 5,000. Right? So what is the conclusion? It completes 5,000 oscillations. You see, under-damping means very, very lightly damped. 5,000 oscillations before its amplitude decreases by a factor E. Okay, there is 5,000 here given. Option C. So the answer is option C. Have you understood the whole idea? Don't proceed very blindly. Of course, you can't be thinking all those things in the examination hall, but you should have a prior knowledge of what are damped oscillations, what is under damping, what is critical damping, what is over damping, all those things. So if you know all those things, maybe I took a longer time to finish it because I gave a lot of explanations. Otherwise, you have to simply evaluate things here and there. If you are very good in calculations and all, you can easily do the calculations. Particularly this approximation you have to be using. Then only it will match with one of the options here. You don't have to be seriously calculating this because the time is running out. Right? So even even though the damped oscillations you are not studying with care in your CBSE 11th standard, when you are preparing for JEE and exams like that, it's better you study the damped oscillation. You see, there is one question asked recently, 2019 main exam, I told you already. Is it clear? So understand and proceed, then the knowledge of physics will help you to solve any problem. Is it clear? What is the correct option? C, 5,000. Thank you.